Okay, so we're going to look at some more examples of optimization problems. And remember, optimization problems are when we're trying to find the maximum or minimum of some word problem um, or some geometric problem. So this is a classic type of problem where we have a rectangle that is inscribed in between the following graphs. Y equals 4 minus x squared, which is this graph, and 1/4 x to the 4th minus 1, which is this graph. And let's just make this a little bit bigger. So what we have, when you inscribe a rectangle inside, what's going to be the case is that, if this value is x, this value would be negative x. And then we go, up, down. Here's a rectangle. So if we think about the dimensions of the rectangle, it's going to be 2x. That's going to be the width of the rectangle. And then if this is our, if we call this y1 and this y2, our height is y1 minus y2, the difference of those values. So we want to maximize the area. Oh, by the way, this problem is a calculator problem. So some problems that we do, you'll be expected to do by hand. This one, we're going to rely on the calculator. All right, so the area, we have the dimensions to the right over here. So our area is going to be 2x times the difference of those heights. So 4 minus x squared minus 1/4 x to the 4th minus 1. Okay, so and we want to maximize this area. And what we're looking for, just to be clear, when we get a final answer, we're looking for the width of the rectangle. Well, since we can use our calculator, anytime you can use your calculator, there's no need to do unnecessary work. So what we could do is just go to our calculator and graph our area function without doing any work. So we get 4 minus x squared minus so we could graph this, and let's think about what our our window, our y value should be pretty big because we're looking at our area here. So let's look up to maybe like 50 and make a graph. I guess we didn't need to look that high. So here's our area right there. That's our max area. So let's go back down. So this is measuring our area on the y-axis as a function of our x value. So if we want to find out where that max area is, let's go find the maximum value. And we get that it occurs when x equals 1.06. So this happens when, oops, wrong pen, when x equals 1.06. But our question is, what's the width of the rectangle? So the width of the rectangle is 2x. So the width would equal 2.12. So this is a question that you could have answered without any calculus, and we did just answer without any calculus. So if you have the use of a calculator, and the question doesn't demand you to find the derivative and do all of that work by hand, feel free to just find a maximum or minimum value just by graphing the function and finding the max min. That being said, on this next problem, we're going to do this problem by hand. So this is a no calculator problem. So on the topic of calculator, no calculator, the AP exam is split up so that half the problems you can use your calculator and half you can't. So you need to be fluent in both methods. You want to be able to be savvy on your calculator, but you also need to know how to do all of the algebraic work by hand. Okay, so it says a rectangle is inscribed in a right triangle with the sides 6, 8, 10. So um, those dimensions should pop out at you. 6, 8, 10. That's a 3, 4, 5 triangle. And the rectangle is such that it has one side on one base. So the sides lie along the legs of the triangle. So like this. So it shares that, shares this, and then the other side is at the vertex, or the other vertex is on the hypotenuse of the triangle. Okay, so what do we do here? What dimensions for the rectangle will maximize its area? So what we need to do is we need to think about what these heights, what these values are. What, in other words, what's changing? If we call this x and this value y, then this value here, which is the base of this rectangle, would be 6 minus y, and the height would be x. So the area of the rectangle is 6 minus y times x. Okay, but we know that we need to get in terms of two variables. And so we want to get rid of, right now we have three, area, y, and x. So we need to get rid of one of these variables. So what we know is that the relationship between x to y, because of the 3, 6, 3, 4, 5 triangle, x over y is going to equal 4 over thirds, or 4 over 3, because of the relationship of a 3, 4, 5 triangle. So using cross multiplication, or rather just solving for y, or solving for x, we can get that x equals 4 thirds y, and then we can take this value and put it in for x. And when we do that, now we get area in terms of one variable. Okay, so in order to find out what the maximum value, we want to set the derivative equal to 0. Well, before we set the derivative equal to 0, it's helpful for us to simplify that area function. So distributing the 4 thirds y, we get that area equals 12y minus 4 thirds y squared. And not 12, that should be 8. Okay, and then our derivative will be 8 minus 8 thirds y. And we want to know when this is a max, so we set this equal to 0. And then solve that equation for y. So we get 8 equals 8 thirds y, or solving for y, we get y equals 3. And if we know y, then we can find x. So x equals 4 thirds y, which is 3. So x equals 4. All right, so the last thing that we need to do is to find the dimensions for the rectangle that maximizes the area. So we found we found everything that we need. Key thing, y equals 3, that's this piece. But the base of the rectangle is 6 minus y, but it doesn't really matter because you get 3 back regardless. So that's the base. And then our x value here is 4. So this is 4. So these are the dimensions of the rectangle that maximizes the area. Okay, we're going to do one more problem here, and you'll be looking at this later on the next day as one of your possible problems. So pay extra attention. It says a rectangle has its base on the x-axis with the upper vertices on the graph 6 minus x squared. And like that. So I'm going to draw this even bigger. So if this is x, this distance is also x. So the total base of our rectangle is 2x. And then the height of our rectangle is 6 minus x squared, which we got from right there. So the total area equals 6 minus x squared times 2x, which if we distribute that becomes 12x minus 2x cubed. And if we want to find out the max area, we're going to find the derivative and set the derivative equal to 0. So the derivative is 12 minus 6x. And this equals 0 when x equals 2. And that's sort of just simple algebra right there, solving this for x. And then just to be extra sure, I know we didn't do this in the last problem, but to prove that it is a max and not a min, we'll do a derivative chart. And we know that when x equals 2, the derivative is 0. For x less than 2, this gives us a positive value. And for x greater than 2, putting it into the derivative, negative value. So that means our area function will have a max because we're going positive, 0, negative. So what's the maximum possible area of that rectangle? Well, now we just put 2 into our area equation. Because remember, you always need to look back and see what is the question really asking. So the max area is 6 minus 2 squared times 2x. So 2 times 2. So we get that this equals 8. All right, there we go. Hope these are making sense.